simplifying and evaluating variable expressions. For all of these videos, it's a good idea to actually write down the problem and take notes, or write down the example and try to evaluate or simplify each of them and then check your answer with my work. But it's always a good idea to take notes. So we have two parts. For the first one, we would actually like to simplify. And then the second part, we want to evaluate. So we are looking at variable expressions. All of these examples are variable expressions. They do not contain an equal sign, and we cannot solve for the variable. We can just simplify. So for the first example, simplify means, in this case, to combine like terms. So we can look for the like terms, which are basically terms with the same variable and the same exponent. So that's going to be 8x to the third and negative 9x to the third. Those are like terms. We can add or subtract those. And then we also have negative x, negative 5x. Those are like terms. We can add or subtract. X squared does not have a like term. We're just going to bring that down as part of our answer. So we are going to combine 8x to the third minus 9x to the third gives us negative 1x to the third, or you can write negative x to the third. Negative x minus 5x gives me negative 6x plus x squared. This is our final answer. We cannot add or subtract any more terms because they have different exponents. Second example contains parentheses, and we have 7 multiplied by the quantity x minus 2. In this case, we have to start off by using the distributive property for this first part, and then we combine like terms. So starting off with the distributive property, 7 times x is 7x. 7 times negative 2 is minus 14. I recopy the rest of the problem. Notice that when you use the distributive property, the parentheses are gone. We combine our like terms. 7x plus 4x is going to be 11x. Negative 14 minus 15 is negative 29. This is our final answer. Last example for simplifying. We have 2 parentheses, and so in this case, since I'm multiplying 1 over 5 and 1 over 10, then we need to use the distributive property twice. When you multiply fractions, remember you multiply numerator times numerator, denominator times denominator. The denominator for 9 and 2 is 1. You can write over 1 if you want. So we'll start off with distributive property. We get 9 over 5y plus 2 over 5 plus 2 over 10y minus 1 over 10. Remember that when we are adding and subtracting fractions, we have to have the same denominator. So we need to get a common denominator for the like terms. I do notice, however, that these 2 like terms, I can actually just reduce 2 over 10, and it'll have the same denominator as the first fraction, which is good. The next 2 like terms, we will have to get a common denominator. Between these 2, the common denominator is 10, and so you do have to multiply 2 over 5 by 2 over 2 to make this denominator 10. So remember, we need to multiply here by 2 over 2. That way we get 10 in the denominator. Reduce. Let's make this a little bit less confusing. Okay. So now I can combine these two. We're going to get 10 over 5y plus these two. We get plus 3 over 10. And I can reduce 10 over 5 to write my final answer, 2y plus 3 over 10. And that's complete. Let's take a look at the second set of examples where we would like to evaluate. And so in this case, we have a variable expression, and then we are told what the variable is equal to. In this case, it says x is -3. To evaluate, take -3 and substitute it for x wherever there is an x for the expression. When you substitute, especially when we have exponents and negative numbers, use parentheses. It makes it less confusing and reduces mistakes. So for this first part, we have to be careful right over here. That negative just comes down. We don't do anything with it. Then we have to replace this x with a -3. Use parentheses, and then the exponent goes on the outside. Plus, I do the same thing here. Use parentheses. Exponent on the outside. Plus 6. Now we can actually calculate what we get. Remember, you have to use order of operations. Order of operations says to take care of your exponents before you add and subtract. And also exponents before you multiply. And so we have to actually take care of this part, simplify this part first. Do not combine the two negatives, because making these two negatives positive implies multiplication. We have to take care of the exponents before we multiply. And so if we do this, this first negative just comes down. -3 to the third power is -27. -3 squared is +9 plus 6. Now, since the exponent has been taken care of, I can now just write +27 plus 9 plus 6. And all we have to do here is just add 27 plus 9 is 36, plus 6 is 42. Example 2, here's the expression. In this case, we have two different variables. Y is 3 and x is -1. So we're going to replace. So replace y with 3. I don't need parentheses because I don't have any exponents or negative signs. You do need parentheses here. Negative parentheses -1 squared. 3 comes down. Again, right here, we have to take care of the exponent before we write plus. So do not make this a plus. Take care of the exponent first. This negative comes down. -1 squared is +1. Final answer is 2. Last example, we are going to input 5 for x, -1 for y. So let's do that. Order of operations. There are no exponents here, so we're just going to multiply first. Right here, I can make this +1 because there is no exponent here. So then we just move on to writing it as +1, and our final answer will be -4.